Well, welcome to another exciting Java class. I think that some people noticed that the homework was assigned so that it would be due today rather than yesterday, and that's because I made a mistake with Blackboard. But I own this mistake, my mistake, and so it's due when it's due. It's due today instead of yesterday, and that's fine. So you can enjoy the extra time. But please don't wait till the last minute to submit and then come to me and say, oh, professor, I couldn't submit because of blah, 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 blah in the network, because you had it the whole extra day. And I'm not going to do that for next time. And in fact, for next time, I'm trying something a little bit different with Blackboard. For next time, what we're going to do is we're going to do the same multiple answer format, but with a difference. And the difference is you have 120 minutes in which to complete the exam. So once you begin it, it will auto-submit after 120 minutes. And there's no backtracking. So you'll have to go through in one pass. So what this means, I think, is that some people will have to do their own work. What has happened is the grader, Chatyana Nala, has said, the students are not learning. And so I called up Mary Kleps, the Blackboard person, and I said, my students are not learning. And she says, well, what can I do about that? Because I'm just the Blackboard person. And I said, well, we have to find some other way to administer the tests or the quizzes or the homeworks. And she says, well, let's discuss it, and now we're trying something a little different. If it doesn't work out, well, we'll just have to figure out something else. It's very good for people to be able to help one another, but you will not get the benefit if you just copy. It's not good. So I'm trying to get people to actually read through all of the letters and to really think about the homeworks. I'm not trying to be a pain. I'm wanting you to do the reading and to actually, think about the tests and or the questions, and think about the Java a little bit. The course gets a little bit tricky at this point in the semester because we start to work with what I think of as the most conceptually difficult part of the Java programming language, and that is the nested reference data types. So if you recall, in the last two chapters, we worked with first exceptions, and then with packages, and then comes inner classes and inner interfaces, or what we term in the book nested reference data types. And so before I proceed into that topic, what I want to do is make sure that you don't have any leftover worries or doubts about the prior chapters. So is everybody still on board and on track with exceptions and packages? Because I know last week there were no questions. But now there's a homework assignment, and it's due today. And you have this opportunity to ask questions if you have any questions. No questions? Everybody is just so brilliant.
Actually, I have a doubt.
Yes, please.
Does polymorphism can throw exceptions? It can also throw exceptions like unchecked or checked exceptions.
Okay. Can polymorphism throw an exception? Is that your question? So the answer is yes. When you try to assign a reference data type to another reference data type, you can get what's called a class cast exception at runtime. And I think we demonstrated that. What you can do is, let's assume that you have, I can do a nice example here if we didn't do one from last time. Yeah, here's the exceptions chapter. So let's try an example involving something a little bit new. I'll devise this one from scratch because of your question, and we'll call it the polymorphic, polymorphic exception. This directly addresses your question, I think. So what we'll do is we'll have a class inside of the polymorphic exception class, and what we'll do is we'll create a little main method. I would like to make an example that will throw an exception that's as simple as I can make it. So let's assume that you have a capital I integer. Now, capital I integer is an example of a wrapper class. In other words, I of capital I integer type is a reference data type, which can be set equal to a new integer, and that can be made from a primitive data type, such as a number, like 14. So now I has the ability to give us certain, I'll call it, methods, right? And the methods are toString, toByte value, compare to, double value, float value. It can do conversions, and that's fine. But now suppose I decided that I wanted to take I and convert it into some other data type. Let's assume that I wanted to make a polymorphic exception. I'm going to create one deliberately, just because of your question. So my polymorphic exception, PE, is set equal to, and then I'm going to cast it to polymorphic exception type. But first what we'll do is we'll just say it is equal to I. And he says, I'm sorry, but I do not know how to convert an integer into a polymorphic exception. I'm going to say, aha, well, trust me, Mr. Compiler, I know what I'm doing. I'm a professional Java programmer. So what I will do is I will get around this little, red thing here, and I'll just write, here, trust me, it's a polymorphic exception. And it says, aha, I don't know how to do that. He says, I cannot cast an integer to polymorphic exception type. So he says it's inconvertible. Inconvertible. It's an inconvertible type. Well, all right. Suppose I said to you, let's convert it to an object. Oh, I know. We'll keep it as an integer. And then we'll take the integer, we'll make it into an object. So that's okay. And now what we'll do is we'll take the object and we'll make it into a polymorphic exception type. So there, I win. I win. Right? I told it it was a java.lang.object, which is the primordial object from which all classes must descend. I converted it into this data type, and then I said, oh, here's an object. I just cast it to polymorphic exception. And the compiler says, okay. Good. And so I said, great. Let's compile it. And I think I can just compile it, but I would rather just run it. Well, let's compile it and make sure. I'll compile it. Compiler will compile it. Make bytecodes. Bytecodes come out. Class files. That's just fine. And then he likes it. Yay, I win. I win. So I've made an instance of the polymorphic exception. But I think it isn't going to run. Because at runtime, when you try to cast an integer into something of polymorphic exception type, I expect the runtime to become confused by these two different things. It doesn't know how to convert an integer into a polymorphic exception. And so what it will do is it will give me a class cast exception at runtime. So polymorphic exceptions can happen. Here's an example where the compile time exception is fine, but the runtime exception, well, there's no compile time exception, but at runtime he says, aha, class cast exception at runtime cannot do it. So with polymorphism, if you have data type conversions implicit into the casting, if it doesn't work, then you're going to have problems. So it is possible to throw exceptions with polymorphism. What do you think of that? So what does this mean to me? It means if I go out to the file system and I read in an instance of an object like payroll, and then I try to cast it to something like customer, well, a customer is not a payroll. And so I can't do that casting at runtime, so I can get a class cast exception at runtime. Does that answer your question? Okay. Any other? Can I try and catch this exception? Sure, why not? And if I can catch it, maybe I could do something about it, right? So let's take some code. We'll try and catch it. So we'll surround it with the try-catch block. And if it throws an exception, it'll say something to recover. Like, for example, you can't do that. And then the program thread of execution can continue. So then after the try-catch block executes, you can continue by printing out something like done, or whatever it is you want to do. So now it'll try and catch the class cast exception at runtime, print out you can't do that, and then it will print out done. So instead of printing out the exception, it just gives us an informational message that says don't do that, and then you can go and continue with the program. The program doesn't have to fail. You can recover gracefully. So maybe the exception at runtime will be something like this. The merchant says he has declined the credit card, so it gives me some informational message in HTML on the screen in the browser that says, credit card declined, please change payment method, or alter your verification or whatever. And then it gives you a chance to recover and gracefully check out from your shopping cart scenario. So in principle, the exception allows you to handle the business logic of some failure in a graceful way. What do you think of that? Good? Any other questions about packages or exceptions or anything that's come before this chapter? All right, so we're into nested reference data types. And there are two kinds of nested reference data types. There are nested interfaces, and there are nested classes. And there are two kinds of nested classes. There's dynamic nested classes, and then there are static nested classes. With dynamic nested classes, it's important for you to make an instance of the containing class. And with static nested classes, you do not need to make an instance of the containing class. I'll bet you most of you didn't understand what I just said. I'll bet you. I'll bet you. So what I'll do is I will give you an example, because nothing is more annoying than a good example. And what we'll do is we'll start with nested classes, and we will make a static class. Let's make a new Java class, and we'll call it nested static. I don't know, what shall we do? Oh, fruit. Let's do nested fruit. Oh, I know. Let's call it the fruit nest. That's good. No, I got a better way. I got a better one. Let's make it the rat's nest. Yes. From a rat's nest to the very best. So in the rat's nest, we'll have two kinds of classes. Right? I know that rats come in laboratory rats, which for some reason, they're seeming okay. And then there's the common rats, which are perhaps viewed in a dimmer light because of the diseases which they carry. and they eat in the garbage and do other things that they're regarded as unclean. So what we will do is we'll have two kinds of rats in the rat's nest. The first rat will be we'll make it a static class, and we'll call it a lab rat. Lab rat. And the lab rat is a different kind of class from another static class. Whoops. I got the mouse, but I still get hung up by this trackpad because it wants to intercept my motions. And the other one is, how do we call this rat? The non-lab rat. Does it have a common name? Junk rat? Garbage rat? Disgusting rat? Brown rat? What is the non-lab rat called? Does anyone know? Anybody know about rats? No? I went to Hawaii once. They're all over the place. Apparently they came over in the European ships and they let them loose, and they don't have cats, so they just decimated the tropical birds. They eat the eggs and things. And they run around. No one will kill them. So let's call it the rat rat, because I don't know what to call it. It's just a rat. So now I've got two rats, lab rat and a rat rat, both rats. But this one is a little bit different from the other one. Let's give it a property. Let's call it Boolean, and we'll make it clean equals true. And the rat rat is a little different. This one is Boolean clean equals false. I think the reason why they like the lab rats is because they want to use them for experiments, and so they want to make sure they're disease-free. So then when they give them diseases, they know it's just them that caused them to be sick. So now we'll make a main method, and if I want to have access to a lab rat, I can go into my rat's nest and make a new instance of the lab rat, and I can do it this way. I can say lab rat LR equals new lab rat. And that's fair, right? I didn't have to make a new instance of the containing class. And I'm inside of a static method. I can also make absolute reference to the lab rat by making reference to the outer class. So I can go into the rat's nest, dot, and go to the rat rat, RR, equals new, and then I can say rat's nest dot rat rat. Oops. Dot rat rat rat. Rat's nest dot rat rat. Rat's nest. There it is. Dot rat rat. Boy, that's annoying. He just went to new rat rat, and he took out the rat's nest prefix because he knew I didn't need it. IntelliJ is sometimes too intelligent, even for its own good. So what we'll do, since IntelliJ is so smart, is we'll take the main method and we'll move it into a rat's nest example class. So let's move it into the rat's nest example, and what we'll do is refactor. We'll create it. What is he up to? Looking for usages of main? Are you kidding? You don't need this. He's giving me a hard time. let's just make it public. Move from to, he's actually giving me a very difficult time. I'll just make a new instance of a class. Let's call the class Rat's Nest Example. And then what I'll do in the Rat's Nest example is I will grab this main method. There. That'll get them. So now in the Rat's Nest example, I've got the main, and now he says lab rat, right? But we know lab rat lives in Rat's Nest. So I say Rat's Nest dot lab rat. And here I say Rat's Nest dot lab rat. And now we have Rat's Nest dot rat rat. How's that? So now it looks like you need to make a reference to the containing class, the outer class, called the Rat's Nest, in order to get access to the lab rat. And in fact, if we have these outer classes containing the inner classes, it looks an awful lot like packages. And if you think about it, java.awt.frame and java.awt.button, that all looks like outer classes. An outer class named Java with another class named AWT with another class named Button. And so, in a sense, using static methods, you really don't need packages, right? Because it all looks like the same thing. Why would you bother with packages? Can anybody answer me this one? I mean, if you can use packages to contain your namespace, and if you can use outer classes to contain inner classes, what's the difference? Why should I need packages? Does it make sense? Suppose I said to you, well, gee, you know, I've got a class, okay? Here's a class, and it's called java.awt.frame. Yeah, that's a decent class, and it makes a new instance of a java.awt.frame. Okay, and that's it. Wow. Wow. Doesn't seem to me like this needs to be a package. I could probably do this on my own, right? Suppose I said to you, well, okay, go ahead and do it. So here it is, class Java. That sounds like a good name for a class. And here's another class. We'll make it static. And we'll call it class AWT. And that sounds like a good name for a class. Oh, and here's another class, which I'll put inside, and we'll call it, oh, I know. Let's call it static. Whoops. What did you do? This trackpad is driving me nuts. Can you turn the trackpad off? Is it possible? Class frame. And then there it is, java.awt.frame. So which frame is this? Is this the frame in the java.awt package, or is it the frame in the Java class, which contains another class called the AWT class, which contains another class called the frame? Huh? Which one is this?
Frame in Java class.
It's which one? It's the static outer class, right? Java.awt.frame. So when I go to the definition, there I am. And if I want to make a new instance, I can put in a constructor, and I can write something out here like hello from frame. Hello frame. Hey, isn't that fun? And so now I've made a replacement for the java.awt.frame, which is part of the Abstract Window Toolkits frame. And in this particular frame, isn't this fun? I have a nested reference data type consisting of two static classes. Very fun. Isn't that fun? And now when I run this, in theory, it should say hello frame.
Professor, but it increases the lines of code.
I increased the lines of code.
No,
I don't care. I made something really, really interesting and confusing. Right? It says hello frame. What happened to my java.awt.frame? It's gone now, right? I just erased it. You're saying this is confusing and there's many more lines of code than you need and no one would ever do this because this is stupid. Okay, I'll give you that.
can you explain this once I didn't get your point? Like
Well,
what?
you know that if I change this to AWT.2, for example, then over here you will get different behavior because now you're using the java.awt.frame, I think. Let's see if we confuse the compiler before we confuse the students. Cannot find symbol. How about that one? Huh? Huh? Pretty good. So the runtime had troubles there. That's very interesting. Where did it find that frame? Let's play find the frame. There is no java.awt.frame in the class. Let's see. Yeah, he knows it's java.awt.frame in the menu container. He knows where the definition is. It's part of a window system which resides in. Let's just make sure we can get to the top here. There should be a package statement, right? Oracle gives us source code. Somewhere in here there should be a package statement. There it is. So there's a package. And the package is called java.awt, and that gives me an abstract window toolkit which contains classes like a frame, which I can display and show to you to build a graphic user interface. But then me, personally, I said, I'm a Java programmer. I can do what I want. I'm going to make a class called Java. You should never do this, by the way. Right? Do as I say, not as I do. Don't do this. But if you're going to do it, at least you know that what you're doing. And so what this is doing is it's saying, in the namespace that I'm presently at, in the rat's nest that I've built, I've created my own reference data type called the Java class. Well, I no longer have access to the package called java.awt.frame if this reference type has priority at the runtime. So what I've done is I've created a static nested named class called AWT, which contains another static nested named class called frame, and inside of the class Java I have a class called AWT and another class called frame. And when you make a new instance of the java.awt.frame, the constructor frame is invoked. That returns nothing, not even void, and then says hello frame, right? And so what happens over here in the rat's nest when you make a new java.awt.frame is it invokes the constructor and says hello frame. That's legitimate. You can do that. But now you can't proceed to assume that that frame is the frame that resides in the AWT package. Different frame. So you can use nested reference data types in order to organize your namespace, just the way packages do. So then the question is, what do we need packages for? That was my first question, right? What do you need it's a waste of time. Who needs it? We have nested reference data types. We should get rid of packages and rewrite the whole thing and just put it all in one class. Does that make sense? Yes? No? You don't like my... Why not? What's wrong with my brilliant idea?
Because actually, if you import package, it will like code will decrease and there is no confusions. If you write whole thing, like giving reference data types, it may confuse. But it idea is very good.
Well, suppose I said to you, I want to import something from a package. So I say import Java dot, and now I see there's a whole bunch of sub-packages. I don't have to import everything. I pick what I want to import. So I just want to import the AWT. And then I say dot, and I don't have to import everything. I can pick what I want to import. So I just import the frame. So now what I've done is I've changed where the compiler has to look in order to find references. So this makes compilation faster. It only imports one thing. And I also change where the dynamic loader has to look in order to grab access to something like a frame. It only has to look at one thing. Not only that, but when you go to compile, you don't have to compile the whole Java dot everything. If you made one change in frame and it all resided in one big file, the whole file would have to be recompiled every time you changed one thing. So this is a stupid idea, and no one should ever do it. That's not the way you design, There are packages are there for a reason. What you want is separate compilation. You want to make it so that you're dynamically linking and loading to only a few classes, only the classes you need. And so what you want to do is you want to try and speed up your compile, debug, and execute cycle, because that is going to define the limit to your productivity as a programmer. So your goal in all of this is to try and make maintenance a little bit less expensive, because 80% of the cost of software in its life cycle is in maintenance. And so when you go in and start to change things around, you'd like to contain complexity and contain what has to be compiled. That's what packages do. So this approach to nested reference data types isn't good for organizing large namespaces. It's good for organizing small namespaces with casual creations of small classes. So once you try and scale this to some big system level thing, it doesn't work very well. But for small classes, it's great. What do you think of that? That's some example, huh? From a rat's nest to the very best. So what have we learned? That static nested classes can be instanced without instancing the outer class. You can make direct reference to them. Moreover, you can use them for other things. For example, suppose I said to you there's an interface that we can use to describe rats. How about this? Interface, whoops, this is terrible. Interface mammal. And if you have an interface for mammal, then you'll have a final Boolean for a property has hair equals true, because mammals have hair. Whatever. So now what we can do is we can say that the rat's nest example has two kinds of animals associated with it, lab rats and what's the other one? Rat. So both of these can implements mammal. And this one can also implement mammal. In fact, they could implement rat if you want, and then you could just have all kinds of properties for rats. So then you'd have two kinds of rats. Both of them implement the same interface, so you can use them for polymorphism. Not only that, but you could get instances from the rat's nest. So instead of making a new instance of a lab rat, you could invoke rat's nest dot get new instance. And in doing so, you create what's called the factory pattern. So in the factory pattern, what we have is a design pattern that enables us to gain access to instances. So what we'll do is we'll get a mammal. And let's do this. We'll say mammal get rat. Get rat. And then we can see whether or not it's a lab rat or not. So we'll put in a Boolean. And the thing is going to call is lab rat. Shoot. If is lab rat, return new lab rat. Else return new rat. Ah. There. So now I've got my new, I'll call it design pattern. I call it the factory pattern, and it makes new instances for me. Moreover, I can prevent others from making new instances of rat or lab rat, and I can do that by making the classes private. So now, for the first time, because we never saw this before, we have an access modifier, and it's applied to a class, and that access modifier, which we could never see before, is private. So now I have a private static class. It's a nested reference data type, and it's created a series of errors. And those errors came about because outside of the rat's nest, someone tried to make a new instance of the lab rat directly. And you're not permitted to do that because these are private classes. You have to go through ratsnest.getRat. So now, this is kind of neat. The reference data type is actually hidden from view. But the other reference data type, which we knew from before, mammal, is not. So they're both mammals, and so they should have no trouble casting to mammal data type. So that'll work. But now when you go to the rat's nest, you can't just say new rat's nest. You have to say ratsnest.getRat. And the type must be true if it's a lab rat, and getRat has to be static. And now if I want a rat, then this has to be false. Now, what's wrong with this? Oh, he wrote new. Yeah, that's not good. What do you think of that? So now I got the factory design pattern. I got static nested reference data types. I got the ability to make new instances using factories, which I can parameterize, right? Not only that, this is kind of cool. As people call getRat to make new instances, I can keep a rat count. So I can know the total number of rats that have been created. So I'll keep that in my rat's nest so I can know how many rats there are around. Because if there's lots of rats, it's good to know, right? How many rats are there? Lots. Well, we'll know because we'll have a integer which is static. We can even make it private. Integer, I'll call it rat number. and I'll set it equal to 0. And now every time somebody calls get rat, I will increment the rat number. So I can keep track of how many rats there are. Now, what do you suppose is wrong with this? Why is it red? You tell me.
Make it static.
It has to be static, yes. It has to be static if you're invoking it within a static method. And now you're good. And now, suppose you wanted to gain access to the rat number. Would you ever want to set it externally? No, right? Because it's being maintained internally. But you'd like to read it. So you want to have it as a read-only variable. How would you make it as a read-only variable? Do what now? You have to trick your mouth. Mumble like you mean it, so I can hear. So, does someone have an idea? Read-only variable, not writable? You can't set it because it's being set already. Every time someone gets a rat, we increment the rat count. But if you want to know how many rats there are, you need a class variable? I don't need a class variable. I've got the rat number. It's already known.
Final.
If I make it final, I can't change it. I want to change it. To make it readable to people who are outside of the rat's nest, I better provide a method, right? And the method is called a getter. Right? So I say public get rat number. And I return, whoa, the rat number. So now when somebody is interested in how many rats there are in my rat's nest, all they have to do is call get rat number and they'll know. So someone out here said, I'm making rats. Here's my lab rat, here's my rat. Now I can go into the rat's nest and I can print out how many rats there are. Rat's nest dot get rat number. Oh, shoot. But get rat number isn't working. How come get rat number isn't working? Well, you spelt it wrong. That won't help you.
No.
Rat number. Yeah, so how come it's not working? You tell me, Java programmers. My grader says you're not learning. Tell me I'm wrong. Tell me he's wrong. Tell me you are learning. What's the bug? Pretend this is a homework assignment and you're stuck and it's turned red and you don't know what to do. I could just imagine the email. Oh, Professor Lyon, the compiler is broken. It won't let me compile. I could say, well, I don't think the compiler is broken. Maybe your understanding of Java is broken. Right? What can I say? So why is it red? Why? Rat number is static. What about get rat number? Is it dynamic or is it static?
It's dynamic.
It's dynamic, and it's making direct reference to a static. So what do we need to do to make direct reference to this method? We have to make it static. Ah, shoot. Are you sure there's nobody out there who knows how to turn off a trackpad? I think it should be possible. I wish I could understand more about trackpads. So anyway, now we've got a way to print out the number of rats. Let's test our mechanism for rat counting. I think it will print out 2, because I see only a lab rat and one rat. And there it is. So now it looks like we've learned about design patterns for making new instances. What do we call design patterns for making new instances? Factory. Thank you. You've been brainwashed. Good. So this is the factory design. Actually, it's education. We don't call it brainwashing. Although, I think in China they call it education too. But they do it in a gulag. So then, as a result, what did we learn? That we can make nested reference data types with static classes. That we can make reference to the instances to the classes directly. That we can protect those instances by making them private for the first time and use the factory design pattern to grab the instances. And we can even use the factory design pattern to keep track of how many instances we've made. Pretty good, right? I'm pretty happy with this example. Does anybody have any questions about it before I move on to dynamic classes? Are we good with static classes now? Okay. Why do we have static classes? Why do this? Why? Somebody put it in there. It wasn't there from the beginning. JDK 1.0 did not have nested reference data types. It didn't have it until JDK 1.2 or 1. I forget. I was there when they put that in there, and I said, what are they doing? Why did they do this? Why? No ideas? How about a guess? It's okay to guess in this class. I'm going to guess, because I don't really know. And my guess is that they wanted to give you another way in which to organize your reference data types. That's all it is. It's another way to think about organizing your reference data types. Let's do another one. I'll do a dynamic. Right? We had 2 kinds of nested reference classes. The first was static. The second is dynamic. Let's try a dynamic one. We did rats. We probably want to...
In this, we can't overriding the methods.
You can't override methods?
No, because static methods. Like,
I think you can. Want to try?
yeah.
Let's try. We'll override a method. Let's see. What would be a good method to override? We don't have much inside of the rat's nest. Oh, there's something in here about Boolean. It looks like lab rats are supposed to be clean. What if we had a different kind of rat? Private, static. Let's call this class an infected lab rat, which extends, it's a kind of lab rat. So if it's infected, what do we say about it being clean?
False.
False, right? So now we'll just say something like this. Clean equals false. Well, that didn't seem to work out. Oh, it's got to be Boolean, right? Boolean. Clean equals false. So there. I've shadowed the value clean with a subclass and overridden its value. I can still gain access to the superclass. I could do it here. I could say Boolean and then say was clean. And I can set that equal to super.clean. So I can find out that the infected rat was clean, but now is no longer clean. And I can still have access to the superclass's clean property. So my goal in showing you this was to give you an example that contradicts your understanding about shadowing or overriding either properties or methods, because you can do either with static, nested, reference data types. How's that grab you? Everybody understand about super? Super makes reference to the superclass, right? Clean, that's a dynamic property. Now, what if clean were a static property? Could we do the same thing? Why not? Totally fine. Not only did you override the static method, the static property, but you overrode it with a dynamic property. How about that? Pretty slick, right? So you can do that. It's permitted. It's a good thing I started this example from scratch, because if you tried to dive into it after it was already assembled, you would never be able to explain it. So let's leave the static classes alone for now and move on to the dynamic classes, unless there are questions about static classes. No? Good? So suppose I had a point, right? Points have x and y coordinates. I could have a point that's double precision, and I could have a point that's single precision. Or I could have a point that's 2D, I could have another point that's 3D. They could all reside inside of the point class. And they could all be of point type. They could all be of point type. They could extend the outer class. So you can extend either an interface or the outer class from within the inner class. So that's kind of neat. Gives you a general ability to organize your reference data types. Let's do a new Java class. And let's call this one dynamic inner classes. So we'll create a class, and it's going to be a nested reference data type, and this one is called fruit. And it has an abstract class called, an abstract method called get calories. And because this is an abstract, let's see, abstract integer, because it's an abstract method, it has to be defined inside of an abstract class. And so what we've decided is that fruit must have calories. But because I don't know what kind of fruit it is, I cannot know how many calories it has. Because different fruits have different calories. Some fruits could be big watermelons. Other fruits could be like little apples or even tiny grapes. So I would like to know if I can implement a class dynamically using this abstract class idea. And so let's assume that I have a new class, and this class is called Apple. And the apple extends fruit. Well, he's giving me a hard time. What is wrong? Why can't I extend the fruit? Because I have abstract. So I have to implement the methods, right? And so the method is get calories. And so now what we'll do is we'll say apples have 100 calories. Right? So that's fine. It's almost like I have the ability to make direct reference to a dynamic class. Inside of a dynamic class, that's a fine thing to do because the fruit does not exist at compile time. It only exists at runtime. And the only time when the fruit class is going to have access to, is going to be available, is when you make a new instance of the outer class. Let's try another class. I need an example fruit. How about this one? We'll call it the orange. And that extends, also it's a kind of fruit, so this is polymorphism, fruit. And it's now going to have its own implementation of the calories. And maybe oranges have more calories, I don't know. I'll make up a number. They have 150 calories, and apples only have 100 calories. And so now I want to use apples and oranges. They're both fruits. So I'll make an example, and I'm going to call this class the apples, let's see, we'll call it the fruit basket. And it has a main method, PSVM, Control J. And in fruit basket, I want to make a new instance of, I want apples and oranges in my fruit basket. So how do I get one? How do I get apples and oranges in my fruit basket? I got a reference data type. Can I just type fruit? Dot apple? I can't do it. Oh, maybe it has to be uppercase. How do I get this fruit? I want the fruit. Before I had a static nested reference data type, but this is not nested. Right? Oranges aren't inside fruit. Oranges extend fruit. But oranges reside inside of the dynamic inner class. Right? So what I need to do is I need to make reference to the dynamic inner class. So there's dynamic inner class.apple, and I know it is a kind of fruit. And now Alt-Enter should enable me to gain access to it. But look, it's got the wrong fruit. That's not the fruit I want. So what do I do? How do I make a new instance of an orange? How do I make a new instance of an apple? Maybe I should make a new instance of the dynamic inner class. Oh, you like that? Okay, let's do that. So we'll make a new instance of the dynamic inner class, and we'll call it dynamic inner class D equals new dynamic inner class. That's fair, right? So now the dynamic inner class exists, D dot. Now I can gain access to one of the reference data types, apple. But now what? D dot apple A equals new D dot apple. He's unhappy. What do? I can't gain access to the reference data type. Oh, I'm stuck. I need Java students. I need smart Java students. Are there any smart Java students here? No? Oh, no. What will I do? Somebody has to help me. Can no one help me? I have to do D dot fruit. Oh, okay. D dot fruit? No, it's unhappy. Can I say new D dot fruit? Well, we know that the fruit is abstract, but we know class and apples and oranges are both kinds of fruit because they extend fruit. How can I make a new instance of an apple, and how can I make a new instance of an orange? How can I do this? Well, what about the factory design pattern? We can do this. How about this? If we know they both return fruit, why not get some fruit? So let's make a class return of fruit and call get fruit, and we'll go with a Boolean. And the Boolean will say is orange. And if it is an orange, then we return a new orange. Well, we say if, right? If is orange, then return new orange. And otherwise, return new apple. So now I can call dynamic inner class.getFruit, and her fruit will come back. And it'll be an apple or an orange depending upon whether it's true or false. So now D dot get fruit true, and this returns a type called dynamic inner class.fruit. But what happened here? He wouldn't let me make reference to it. What should I do? Will it let me make reference to fruit like this? No. So what can I do about fruit? How about if we make this one static?
What is dynamic?
You can't make a static abstract class? I think you can. Dynamic inner class dot fruit. And so now the dynamic inner class dot fruit data type is being returned by d.getFruit. I got another one here. I can get a dynamic inner class fruit, and I can call it F2. And then I can do d.getFruit and return false. So now I have dynamic nested reference classes and polymorphism and factory design pattern. Sweet, right? Look at all this fruit. And maybe I can add up their calories too. Integer F1, let's see, integer cal, because I'm eating all this fruit. It should be f.getCalories plus f2.getCalories, because two kinds of fruit. And so now when I print out fruit, what is the answer? Presumably you ate an orange and an apple. So if an orange is 150 and apples are 100, presumably you got 250 calories, and now you've had a snack. This class is making me hungry. It's my own fault. We should have gone back to rats. Oh, look. So we added up the two different fruits. And it's an example of polymorphism because all fruits have calories. It's just that different fruits have different calories, which is just what you'd expect from different fruits, apples and oranges. What do you think of that? Can we compare apples and oranges? Well, sure. How would we compare them? Well, we could use calories. We could say vitamin C. We could say whether or not they have pits or how much they weigh. But now all the thing I know about apples and oranges is that they have calories, right? So this is, obviously there are other things we could compare them on, like whether or not you can eat the skin. Well, probably you could eat the skin of oranges, but you wouldn't like it because it's very chewy, right? Well, actually, sometimes I think they grate the orange skin into the pastries to give it that extra zing or something. They do it with lemon rind, too. But in general, you're not supposed to just eat the orange skin, I think. Well, maybe if you tried it out and it became sweetened or something, perhaps you could do it. But in general, you wouldn't. In any case, we've got off track. There are these oranges and there are these apples, and we have a way to compare them. But how would I do that? How would I make a general way to make things comparable? Comparable. I know.
Get instant.
Suppose there were an interface called comparable. We could implement the comparable method, and then any two objects which implement the comparable method would enable us to compare them. So suppose we did something like this. Extends fruit and implements comparable. Comparable. So a comparable object looks like there's a few of them. This one is called comparable to. I like that. Let's use it. And comparable to, let's take a look at it. He says you have to provide implementations for equals, is less than, or is greater than. So if one object is the same as the other object in some respect, then you return equals is true. If the other object is less than the, let's say, calories that you have, then you return is less is true. So let's provide implementations for the comparable to. So what we'll do is we'll let IntelliJ help us a little bit and implement those methods, is less than and is greater. So now the other object must be a kind of fruit, which enables us to get calories. So what we'll do is we'll get our own calories, and we'll return the other object by casting it to is fruit and then getting its calories. So we'll get our own calories, and then less than the other object, which must be of type fruit, because we can only compare ourselves to fruit, and once we have it, and we better put this in parentheses, we can get the calories. So what we've done here is we took the other object, cast it to fruit type, got its calories, then we got our own calories, and we said if our calories is less than their calories, then is less will return the value of the less than, whether it's true or false. Similarly, we can return get calories on our own and then proceed to cast to something of fruit type the other object and so that'll determine, because it's comparable, whether our calories is greater than or less than their calories. So what is other? Other must be something of fruit type. What if other is not of fruit type? What's going to happen? It won't be false, it'll be an exception. What kind of exception? Class cast exception at runtime. I can't compare apples with payroll because payroll is not a kind of fruit. So if you pass payroll into my apples for comparison, the comparable will try to cast it to something of type fruit. The runtime will say, sorry, payroll cannot be cast into fruit. Right? Well, how does it do that? It doesn't know. Payroll is not fruit. So then it cannot have calories. So now I've got all fruits. Let's see, oranges extend fruit and implements comparable. What about apples? Apples don't implement comparable. Do I have to take all this and repeat it for apples? If you have to duplicate code into multiple classes to get your code to work, in the world of extreme programming, that is called a bad smell. That's a bad smell. You don't duplicate code. So how do we as Java programmers prevent ourselves from having to take the code I just wrote for the oranges and duplicate it for the apples? I think my grader is correct. There is no learning here. The answer is you refactor the code so that it goes into the superclass. So what you do is instead of making it orange extends fruit implements comparable to, you make it so that the fruit implements comparable to. So then apples and oranges both know how to compare each other. And so now the code for computing whether or not one element is less than another element the comparable elements all goes into the fruit. So now, because all fruits know how to compare against all other fruits, we have true polymorphism. And they are all comparable, which means I can sort a big basket of fruits as long as they implement the abstract fruit class, which means they have to know how to get their calories, they know how to compare against one another, and so you can build a sort algorithm that works with a giant collection of anything that's comparable. That class of algorithm will rely upon the interface comparable to being implemented. So it can cast objects so that they know how to compare themselves against other objects. Because later, when I'm trying to sort customers, I might be sorting by their name, their wealth, their height, their shoe size. I don't know. But my sorting algorithm will just assume that you've implemented comparable. And then we'll proceed to compare the customers. So now we can sort our fruits based on comparable. So here's the orange, he extends fruit, and he's comparable. The apple extends fruit and is also comparable. And they're comparable based on their calories. And here is an addition of the two calories, but suppose I wanted to compare F1 with F2. is greater than F2. F2 is a fruit. I'm comparing apples and oranges. Now, which one is F and which one is F2? If it's true, it must be is orange. So what we're doing is we're comparing an orange calories as being greater than an apple calories, and we would expect that to be true. So it's 250 calories, and most of the calories are coming from the orange. What do you think of that? Sweet, right? Sweet oranges. Suppose I said to you, I would really like it so that all fruits know how to print themselves, and fruits always have names. How would we do that? Well, if a fruit knows how to print itself, then it must supply a two-string method. And what it can do is it can return the calories, and it can return another string, and the string could be the name. See, how about this one? Get name. Oh, but we don't know how to get the name for a fruit. So if the fruit name is not known, then we have to go back to this abstract class fruit, and we have to provide an abstract string get name. But wait, now I have errors, because anything that implements this has to be abstract. Why can't we just implement the method get name and return orange? And then over here under apple, I can get the name and return apple. So now when you're inside of F1 and F2 and you want to print them, you can print them and they will have a reasonable string representation. What do you think of that? Because all fruits know their names. And they also know their calories. So oranges are 150 calories and apples are 100 calories. So what kind of fruits can we get here? Oranges and apples and that's it? How about if I want to get interesting new fruits and I don't know what they are yet? How about if I want to get a fruit that I don't know? Let's call it the fruit. Somebody said mango. Get fruit mango. How about get mango? That's better. Get fruit mango. We know mango's a fruit. So how about this? Get mango. So if somebody says get mango, and you don't have a class called mango, can't you just say new fruit? And he says no, because fruit is an abstract class. Can you make a new instance of an abstract class?
No, we can't.
You can't? I consider that a personal challenge. I'm going to make a new instance of an abstract class. I'll just implement the methods. And my new mango has more calories than an orange, and it has more calories than an apple. I'll make it up. It has 300 calories. And it has a name, and I'm going to call it mango. And I think I can call my new fruit F3, and now I can call d.get mango. There. And now I'll go and I'll print my mango. F3. And gee, somebody said I couldn't make an abstract class, but I just did, didn't I? I guess somebody was wrong. Oh, but maybe the runtime will prove me to be wrong, and they will be right. Nope, they're wrong. So now there's 300 calories in a mango, and the mango is a class with no name. Because look at this. It's a new fruit, but it's not a class mango. There is no class mango. It just says new fruit. And fruit was abstract, and someone said, you can't have an abstract class. That's what they said. In fact, they were right. You really can't. What I did here is I made an anonymous, dynamic, inner class. An anonymous class actually has a name, but you don't get to see the name. Not in the source code. If you want to see the name, you can. You can see what the runtime sees. And you will see it in the bytecodes that are being produced. Let me move this taskbar out of the way so you can see what's going on. I forgot where it is. This is not good. Oh, book examples. Chapter 12, isn't it? So we were looking at fruit, right? No, dynamic fruit baskets? I forgot what the name of this thing is. It's called dynamic inner classes. So now it looks like there's a $1 in here, where $1 is a name-mangled version of the new fruit. So there's a dynamic inner class, and there's a special name that was automatically generated by the compiler, $1, which enables you to have access to the nested reference data type. Let's see what else is in here. Whoops. Yeah, there it is. So here's dynamic class, and here's, it's a little bit hard to read because it's so cluttered. Let's move this down. And now you can see there's the $apple. That's a nested reference data type which is named. There's the $fruit, another nested reference data type which contains the apple and orange. Here's the orange, but here's the $1, which is the anonymous dynamic nested class inside of the dynamic inner classes class. It's probably a really unfortunate name. So what do you think of that? It looks like a class with no name. And in fact, we do call it an anonymous class. But in fact, internally, the Java compiler generates a name, and they call that name mangling. So we've created an anonymous reference data type. And in the anonymous nature of it is such that it doesn't clutter your namespace, which means you can make new instances with wild abandon. As a matter of fact, you could probably make this a random number and have it come back with random calories. And you can make new instances of new classes, and you can parameterize those instances. So that's kind of interesting too. So that means a parameter can be passed into new fruit, and you can pass in information about it, and it can use that information to make new instances. So you have a parametric mechanism for making new instances. It's kind of neat. What do you think of that? An anonymous inner class. So you can have a named inner class. You can have an anonymous inner class. You can have a static inner class. You can have a dynamic inner class. You can have a named static inner class. You can have a named dynamic inner class. And you can have, in this particular case, what is a anonymous dynamic inner class. Can you have an anonymous static inner class?
If it is.
You can? How would that work?
Because it is at one time stuff.
I could certainly have a static method to gain access to a new static instance, but I don't know that I could make it anonymous unless the static instance were abstract. I haven't tried this. I think it will work. Maybe you're right about this, but it's a little exotic. I think you can probably do it. Does it make sense to try? We're getting a little off the beaten path. It gets overly exotic sometimes. You want to create a static class that's abstract. An abstract static class. I don't think I've tried that before. Let's do that. New Java class. Let's call it the abstract anonymous static Now, how would this work? Well, let's start with an abstract class that's static. Static, abstract, class, roach. We've gone from rats to roaches. I'm not sure that's good, but there it is. And it has an abstract method called get, I know, get name. And it returns a string with a T. String with T. Yeah. So you can have a static, abstract, named class. Now let's make a method, a main method. And in the main method, we make a new roach. and implement the methods and return quote roach. Well, it worked. So now I have a roach R made from a anonymous, this has to be changed, an anonymous static, shoot, this is weird. I've never done this before. We have to try this. When you get a name, what does it do? I don't know. Well, let's just take R and print it. S out, Control J, Enter. I have to try it before I endorse it. Dot get name. I think this should work. Never tried it. Must try it. So the anonymous nested reference data type, it works. Yeah. Makes a new instance of the abstract static class. The named abstract static class has been instanced as an anonymous class with a implementation of the dynamic method that it required for its spec. That's pretty cool. So it's doable. You can do it. And that way you can make lots of roaches, and they can all do stuff. Perhaps crawling around the screen, walking around the screen until they get into the roach motel, where the roaches go in but they don't come out. And then you could have everyone running around in a thread, and you could use your mouse to stomp them with the big boot. You could have a little boot icon. I think they have this thing called Angry Birds. Why don't we do Angry Roaches and just stomp them, stomp the roaches? So we can make tons of these roaches. They can all run around on the screen. I think they're making my nose itch. So that's it, the roaches. So now we have, let's see now, nested reference data types for classes. We know the classes can be named, or they can be anonymous. They can be static, or they can be dynamic. The static classes can be abstract. In fact, you can even make them private. Pretty slick, right? So then if you want to make lots of roaches, you can go to your little roach factory and you could tell it, return an array of 1,000 roaches. And then you can have all the roaches running around on the screen because they're each an individual roach doing whatever, moving small amounts with respect to one another. But they're all independent. Each roach will have its own location and perhaps speed and hungriness. Some roaches will probably be greedy for garbage, whereas others perhaps have a taste for human flesh. I'm thinking that this is a good example, and we could probably code it as a nice Java project for everybody. Because in our next chapter, we're going to have threads, and in threads, each roach can work independently with respect to the other, and it's perfectly okay for us to make thousands of threads, each one of which runs its own roach. I don't sense any enthusiasm from the class on this. Maybe we can do it with fruits instead. So there we have it. How about that? How about those interfaces? We didn't do anything with interfaces yet. We kind of really killed it with the roaches, and I thought that was good. Let's do a new Java class. How about interfaces? So we'll do one called interfaces. Inner interfaces. I think it needs a capital I. There. So the inner interfaces. This is a class, but why can't we make it an interface? So the inner interfaces interface. Does this sound like a stupid name? I'm thinking it does, but okay. Contains an interface, which we can use for our roaches. And one of the things that I like about roaches is that they are moving. So the inner interface for the roaches is they're movable. And let's see now. What do we need to do? Oh, I know. Public void move. And we move them in an integer quantity, a change in x and a change in y. And I don't know yet how roaches move. But that's okay because I know they're all movable. And I'm going to go through every one of my roaches in my list of roaches and make sure that they move by some small amount. Oh, I have another one. Roaches know how to draw themselves. So the interface drawable. I like that. And so what do we need? Oh, I know. Public void draw. Right? I don't know where they are, but they know where they are. It's object-oriented. And they know how to move. As a matter of fact, they probably know how much they want to move, so I'm not even going to tell them. They figure it out. They move. They draw. So roaches know how to move themselves. Roaches know how to draw themselves. That's good. I like it. How about this? I got another interface for the spec on roaches. You can determine if they're alive. So they must be killable because we're going to stomp them. And so public Boolean is alive. So you can determine if they're dead or alive. And so now I've got a nice little collection of properties and methods associated with roaches. I'm liking this. And now they're all under this inner interfaces thing. Maybe what I should do with this interface is call it, these are roach properties. How about we say interface, this is the roach spec. Oh, I know, I have to change it, so we'll do this. We'll change the name and we'll call it the roach spec. So this is my roach spec, and it implements movable, because roaches are movable, and drawable, and killable. So can that work? Alt enter. So roach spec killable. Alt enter. And roach spec movable. Alt enter. And now he's giving me a hard time. Maybe it shouldn't be implements, maybe it has to be extends. And now what's his problem? What did he just do?
Safety.
I was just in the middle of this. I think IntelliJ was a little too helpful just now. There should be a way to undo this. VCS local history. VCS local history. He's not letting me do it. VCS local history, show history. I was doing really good with this, and then all of a sudden IntelliJ came in and clobbered it. I'm sort of bummed by that. I don't want to have to retype it. But the basic idea was that I was going to have a list of nested reference data types. I'm not convinced that I can't get all of that back. Undo deleting. Yes. So is it back? You see it? Roach spec? Oh, here it is. Yeah, I think I got myself into trouble trying to make the single interface. Let's make a new interface that's a composite interface. Interface R extends shoot killable. Oh, that's all right. Drawable and movable. So what we have here in interface R, in our spec, is we have a example of multiple inheritance of specification. Some people say Java has no multiple inheritance, but it does, right? Because what we're doing is we're grabbing from killable and drawable and movable. It just doesn't have multiple inheritance of implementation, but it has multiple inheritance of specification. So this specification is a killable, drawable, movable roach. It does all of these things. And we know that it must have an implementation for all of that, because if you create a class that meets the spec, then it implements the specification for the roach, which means it has to have duplicate class roach spec. Oh, it's already called an interface. Let's give it another name. Let's call it roach implementation. Now we can implement all the methods in all of the interfaces for the composite specification. We click OK. And now we can see a roach implementation that knows how to draw itself, knows how to determine if it's alive, and it knows how to move itself. And what we can do in our roach implementation is we can provide all the properties that we need in order to know where it draws on the screen, how to do the drawing, how to determine whether or not it's been squished, and how to move around on the screen. What do you think of that? Good, right? Roaches. Ugh, makes my nose itch. Okay, so what do we do about the drawing and the implementation for my roaches, my roach implementation? Are you liking my example here? Is it too insect oriented? And integer x equals, I don't know where the roach is, 0. Integer y equals 0. When it draws, we'll just say that it drew at location x, comma y, n paren plus x plus quote, comma, or space, end quote, plus y. And when it moves in some delta x, delta y direction. We can figure that out later, random amounts. What do you think? Little roaches. It'll work. Why not? How many roaches can I make? Lots, right? I could write a separate method to make roaches. I could have a separate class that makes roaches. Could have a whole roach collection, a roach factory. The roach factory class. That's good, right? Because you might need a lot of them. So we could have a whole array of roaches, or perhaps a roach vector, and fill it. You guys can do this, right? We'll have our own little class. We'll call it Roach Motel. Shoot. And in Roach Motel, we have I don't know, a constructor. And then maybe I have a roach collection over in here. And what do? You tell me. Maybe Roach Motel takes a value, total number of new roaches we need, integer n. And so then we have a little for loop. Well, I is less than n, I plus plus. I'm enjoying this roach example. That's very nice. And so now I can say v.add element, new, what are we calling this? Roach implementation? It's a stupid name. Roach implementation. And now you can have as many roaches as you want, all in your big roach vector. That's fun, right? And now, if you want to, you can broadcast a move method to them. Public void move. And now what we'll do is we'll get all the roaches out of the vector. We'll write a little for loop. I plus plus. You got a question? And now v dot element at I will be a movable element. So it must be a roach implementation. So that cast should not give me a class cast exception at runtime, because presumably you've only added roaches there. Although one thing I could do is I could turn this into an object. And then cast it, and then call implementation R equals, and cast it, roach implementation of O, and then say R dot move. So that moves all the roaches around in my little roach motel. They could be very fidgety roaches. The question of how they move, I leave to the roaches. I assume that they will move if they're told to move. And the question of how often you move them and these sorts of things, we can leave to the roaches. They can just move a little bit, and then they can go and draw themselves. So after you move them, you can draw them. So we'll move the roaches and we'll draw them. as they crawl around on the screen. That's very fun, isn't it? Fun with roaches. I'm liking this thing with the roaches. It's very nice. Did I go too fast? No? Did everybody sort of follow along with me on the fruits and the roaches and the apples and the oranges and the what was the mango and the we had polymorphic exceptions and the abstract anonymous static classes and the comparable interfaces and we did a lot today, right? Yeah, I think so. I think it was a lot. And this is, I believe, the most difficult conceptual part of Java. And so I kind of went a little bit fast, but we did some interesting examples. What do you think? Is it sinking in? We did the roaches, we did the apples, we did the oranges. I wonder, and the rats. Oh, yes, let's not forget the rats. Oh, boy, we have fun in this class. So we did the rat's nest, the apples and the oranges, the lab rats, the rats. Yeah, kind of a lot. Well, I can tell you that I actually have PowerPoints for this whole lecture. It's not all fun and games. But if I go through all the PowerPoints really fast, it's like the PowerPoint Death March. Would you like to go on the PowerPoint Death March with me? No. Okay, I don't blame you. Power corrupts, and PowerPoint corrupts absolutely. So maybe what we should do is put aside our little rat's nest and our apples and our oranges. Let's put on our thinking caps for a little bit. What would be a good practical example of using these anonymous reference data types? Well, we've already seen the mangoes, right? Mangoes were a good example of an anonymous reference data type where you just casually created a new fruit that someone else didn't think about, because all I could think of was apples and oranges, but somebody said mango, and I just said, okay, let's make a new fruit. It was an abstract class. People didn't think you could do that. And then we returned our own version of the name and the calories. So that seemed to work reasonably well. And so that gave us some insight, a little insight, into what we can do with anonymous reference data types. Well, what if I told you that in Java there are multiple graphic user interface frameworks? My first question is, okay, what's a framework? Any ideas? Don't be shy. I know that some of you are engineers, and that probably means half of you are suffering from Asperger's syndrome. It's almost certain that you're overcompensating for your insecurity complex, and that's why you're not speaking. I'm really trying to provoke you into participating in the class, right? Okay, so speak up. No? So I can't be the only person talking all 15 weeks. It's not good. I need some class. You know, if you're going to just sit there like lumps on bumps, I'm going to have to start with weekly quizzes. How would you like that? Weekly quizzes. So make me feel better about the teaching experience and participate, please. All right, so you guys tell me. Am I going to torture you with another example because you won't ask any questions? I think the answer is you bet I will. Because you're not going to ask any questions. A framework. What's a framework?
It includes like all set of classes, libraries and all.
Yes, it's a big API that's designed to enable you to do a specific set of tasks. Say it again?
I think it's in a separate window.
In a separate
All
window?
these things.
Well, for example, Swing
Yeah.
is a framework. AWT is a framework. So Swing is a graphic user interface system for designing GUIs like buttons and checkboxes. AWT does the same thing, but it's a different set of classes. So if you have this large set of classes for doing this one particular kind of task, like a graphic user interface, we say it's a framework. So learning the API can be like learning a whole other language. Because there's all these different classes, it makes it a daunting challenge. If you're programming in Windows, you program Microsoft Foundation class library. That's a big framework. But within that class library, there are sub-frameworks for doing GUI, and some for doing communication, and some for doing networks, some for doing serial ports, some for doing other stuff, like Bluetooth. So you can have frameworks within frameworks. Kind of an interesting problem because it helps you to organize your classes, but it also changes the way you think about your programming. Well, one of the things that goes on in the Abstract Window Toolkit that Java has for graphic user interfaces is they give you many different graphic user interface elements like buttons or checkboxes or sliders or frames or panels, or all these things that you see here, like that's a menu item, and this is a menu, and these are hierarchic menus. So with a hierarchic menu, you can see that it pops up to the right. And there's this other thing, it says ... That almost certainly means there's going to be a dialog box. So if you said configure plugins, then the dialog box comes up and starts to interact with you, and you say, aha, there's a checkbox, and here's more buttons. Right? So these are all graphic user interface elements that you have to interact with. They're part of the computer-human interface. That's clear, right? So now when you hit cancel, what happens is you create an action. The action comes from your mouse where you click, it invokes at the back end an action performed method, which takes an event, a mouse event that comes in, and then proceeds to do the cancel thing. You do the same thing with the next button, and then it does the same thing, only it does the next thing. So here's the cancel thing. It did the cancel thing. It dismissed the dialog box and made it so that you could get back to your work. Right? So in a sense, having an action in the back of the graphic user interface is a very common thing because you want to link the business logic with the graphic user interface, the view. So then the question becomes, how many different callback methods are there for all the graphic user interfaces? And for each one of those callback methods, what do you do to implement the specification for that callback method? So if it's the mouse, maybe you need to implement a mouse motion listener. If it's a button, maybe you need to implement the action listener. If it's a slider, maybe you need to implement the item state change listener. And in fact, when you look at that framework, you see there are 22 different listeners with callback functions. Wow. And you have to memorize them all if you want facility with the graphic user interface. That's what it means to learn a framework. So now comes the big question, how can you simplify that interface to this complex framework? And the answer is, well, whenever an action is performed, you can map that action using the interface to a method that requires that something be implemented that's simpler. That's a new design pattern. That's called the facade design pattern. The facade design pattern gives you a simple interface to a complex interface. By simplifying the interface, you get to memorize fewer things about the more complex interface. It's kind of an interesting idea. So If buttons normally require an action performed method, why not make it so that buttons just call run? And if a checkbox requires an item state change method, why not just make it so that the checkbox calls run? In fact, you could make it so all the graphic user interface elements call run. And run can be embodied in a simple class called runnable. And in fact, instead of making it a class, why not make it an interface? So then we'll have a single interface called the runnable interface. And when we implement the runnable interface, we have to provide an implementation for the run method. And someone somewhere said something about roaches. Didn't we talk about roaches? Yeah, I think I remember roaches. I had these roaches, and they were in the nested reference data type, right? And oh, there it is. It's a spec for roaches. And the Roach Motel. And here's the Roach implementation of the spec, right? So if that specification extends killable and drawable and movable, why couldn't it also extend runnable? And when we look at the runnable interface, this is actually part of the JDK since JDK 1.0. It has a simple, abstract method requirement that it be able to run. So anything which implements runnable must have a callback method that says run, which means once this thing is going as a simulation, the roaches should start running. Ooh, they'll be running around. So that's good. So to make it so that a roach will run, we have to provide an implementation for the runnable interface, which means we need a run method. And what it does is it says move and then draw. That's how we'll provide that implementation for the roach. So then the roaches will be running, moving around, doing their thing. How about that? So now, instead of calling move and then draw, all I need to do is call run. And that will call move and draw. What do you think of that? So now I've got a whole bunch of running roaches. Running roaches. As a matter of fact, if I wanted to make something that's runnable, I could have an anonymous runnable reference. Let's try that. The inner run. And what we'll do in the inner run is we'll make something which is runnable, R, by saying equals new runnable. And remember, runnable is an interface. So we're making a new instance of an interface. Can you make new instances of interfaces? Oh, he's very unhappy. He says you can't do it. But if I implement the runnable run method, then I can do it. And so now my runnable interface has to have a run method. I am running. We can even make this static. And will this print? I ask you. Suppose you run main right now. S out, Control J, runner, and you say inner run. What will this print? Will it print inner run, I am running? Or will it print I am running, inner run? Or will it just print inner run? Inner run, because it's not, it hasn't made a new instance of the runnable. Oh, but it's static. And when do static elements exist? At runtime or at compile time?
It comes.
At compile time. So if this compiles, well, it didn't make a new instance of the containing class. Now suppose after inner run is invoked, you make a new instance of inner run. Now what will it print? Yeah, inner run, I am running. Well, that kind of makes sense, but will the run method be invoked? Just because you made a new instance doesn't mean the run method is invoked. So it still doesn't run. So when will it run? Well, the answer is not until you call the run method. But it's not letting me do it. Huh. So inner run, oh, I have to do the R, inner run.r. So ir.r.run. Right? Because R is the instance of the runnable class, and when we invoke the run method in the runnable class, then it should run. So it won't print I am running until you invoke the run method. Now it's doing it. So why is that? Well, IR, inner run, makes a new instance of the inner run, which contains an instance of a runnable implementation which is created from an anonymous inner class. And the anonymous inner class makes a new instance of an implementation of the runnable interface. Does this have to be static? And the answer is no, because you've made a new instance of the outer class. How am I doing here? So I'm giving you the basic Java question to determine whether or not you're getting it from the inner reference data types. And what I'm hearing is maybe not so much. Maybe not so much. So here's the inner run. I've made a new instance of an anonymous implementation of the runnable interface. I provided a run method implementation. This will only be invoked when someone calls r.run. So I went to the inner run instance, made the new instance, got access to the reference variable r, which is of runnable type. I called run, and then it ran. What do you think of that? This is chapter 12. In your next chapter, chapter 13, it's on threads. And what threads need is implementors of the runnable interface. So just to give you a preview on your reading, thread T equals new thread of ir .r. So now we have passed something which is runnable into the constructor's arguments for the thread, and now the thread will run the runnable element when you call t.start. In fact, that's not exactly correct. T.start will cue the thread to start to run the runnable element, and then as soon as there are resources available, it will run it. And so now it should run twice, because the only thing a thread does is it calls run. And it wants jobs that know how to run themselves, so they all have to implement the runnable interface. So t.start called I am running, called run on the runnable, the anonymous class which implements the runnable interface. I think I said that right. So what do you think of that? So now suppose you said you wanted to make another thread. Thread T2 equals new thread. And you know that whatever you pass in has to implement the runnable interface. New runnable public void run s out control j enter, control n enter, control j enter, quote T2, trackpads. I don't know who invented these trackpads. So now if I call T2.start, what you have here is the thread being passed an anonymous reference data type. The anonymous inner class implements the runnable specification, provides an implementation for the run method, is passed into T2, and knows how to run itself, prints out T2 when you hit start. Or soon after you hit start. And that gives you a heads up on your reading in chapter 13. What do you think of that? Good, right? I'm not going to get into the threads now because class is over. But I wanted to give you a heads up so that you can see what you're in for. So when you think about why you needed to know about the nested reference data types, it's because they have a central role when you start to learn about threads. So that's why the nested reference data types came in first, because I use them all the time when I make new instances of threads, because you make new instances of the runnable interface and pass that into the constructor for the thread to run. And so when you make a new instance like I have done here, it's an anonymous inner class. Got that? So you can make anonymous inner classes by making new instances of interfaces, making new instances of abstract classes, making new instances of abstract static classes. What do you think of that? Good, right? You say yes because you know if you say no, you'll never get out of here. All right. Well, have a good evening. I can feel winter is coming on, so you guys are going to have to change your attire. Don't forget that we have real snow coming soon, and it's New England. So you will have storms and all kinds of things. If you don't wear jackets, you'll all get sick. And then I will get sick. So the reason I'm telling you to dress warmly is self-preservation. I don't want you making me sick. All right. Thank you. Have a good evening.